In the first couple of videos of the chapter, we talked about indifference curves and the marginal rate of substitution. The main takeaway of those videos was, first of all, what an indifference curve is. This maps out all of the points that a consumer is indifferent between, or all of the points that gives the consumer the same utility. And the slope of this indifference curve is, in general, negative change in y over change in x. Right, we also know that as a general rule, the consumer wants to have higher utility. The consumer wants to be more happy. So our rule coming away from this is that if possible, a consumer wants to get to the highest indifference curve that they can. Then we talked about budget constraints. All right, if a consumer has a set income, we can map out the budget constraint of all of the possible combinations of the goods that they can purchase. Anything out here we can't purchase, it's unaffordable given our income. Anything inside of the budget constraint is inefficient. We could be spending more money. There's no purpose for saving right now. And that's because we're kind of thinking this as a one-time thing. I have some sort of money and I want to buy things. How do I spend my money? So outside of the budget constraint is unattainable or unaffordable. Inside is inefficient. The possible efficient points are along the budget constraint, where the consumer is spending all of their income. Right, so we want to be able to know then which of these points is optimal for a consumer to purchase, or which of these points will give the consumer the highest utility. So we're putting those two pictures together and it looks like this. All right, we have a budget constraint and then we have a field of indifference curves with U1 being the lowest, U2, and then U3 being the highest. And again, the idea is for the consumer to get to the highest indifference curve given this budget constraint. Right, so what we're going to notice then is that the slope at this particular point of the budget constraint is exactly equal to the slope of this indifference curve. And it turns out that this is going to be our rule for optimality. We're going to be looking for a point where the slope of the budget line, which is negative price of the X variable food over price of the Y variable clothing, is equal to the slope of the indifference curve, which is the marginal rate of substitution, marginal utility of food over marginal utility of clothing. All right, why is that tangency condition an optimal? Well, consider this point over here, right? This is another affordable point on our budget constraint, but it's clear that this is going to be on a lower indifference curve. It's on U1. We could get to U2, which is better for us, by substituting over here to A. Right, likewise, anywhere down here, here's another point of intersection, but that's not going to be optimal because U2 is on a higher indifference curve. Right, so among all of the points on this budget line, budget constraint that we could be purchasing, A, the point of tangency with the indifference curve, is the optimal. Right, so again, we know that the slope of the indifference curve is negative if we have our change in our rise over run, so our negative clothing over food, so our substitution there. We know the slope of the budget constraint, and then at an optimal point, we showed on the graph, those are going to be equal. Right, there's some special cases that we'll want to think about. One is a corner solution. So if you look over here, we can see that the indifference curve is steeper than our budget line at all points. In other words, the MRS is higher than negative PX over PY, or in this case, negative price of ice cream over price of yogurt. Right, so let's consider what we should do in this particular case. We know that MRS is too high. MRS is also the marginal utility of ice cream, our X variable, over the marginal utility of yogurt, and we want to lower that. The last thing we know is that as we consume more of something, the marginal utility falls. So if we want to lower MRS, which is marginal utility of ice cream over marginal utility of yogurt, we could either consume more ice cream. That's going to lower the marginal utility of ice cream. So mu ice cream over mu yogurt falls. Or we could consume less yogurt. This increases the marginal utility of yogurt, and that quantity falls. All right, so we increase our ice cream. We continue increasing our ice cream infinitely down to this point, at which point we're not purchasing any yogurt. Right, so the takeaway is, and this is sort of like what we would call a quasi-linear case. We're going to focus in on the case of perfect substitutes, which are exactly linear indifference curves, but those are still produce corner solutions. The idea here is that if marginal rate of substitution is not equal to the price ratio, then we can add utility. All right, and we want to keep adding utility basically until that marginal rate of substitution is equal. And if we have a corner solution, that's only the case where we're purchasing only, in this case, ice cream. Right, so if marginal rate of substitution is higher than this price ratio, we want to lower it. We do that by producing more of the, consuming more of the X variable, in this case, ice cream. If marginal rate of substitution is lower, we want to increase it. We do that by decreasing the amount of the X variable. Right, there's a section on revealed preference. We're not going to cover that in this class, at least not at this point. We might come back and touch on it at the end when we're doing behavioral theory stuff, but we can leave that out for now. So we know how to find the slope of our budget constraint. It is just negative px over py, and we showed why that's the case. So now what remains is to find mathematically the marginal rate of substitution, mux over muy, mathematically. All right. If our indifference curves are convex shaped like this, it means that it's coming from kind of a multiplicative function, which has what we call diminishing marginal utility, meaning that as you have more of a good, the marginal utility decreases. We'll also see some special cases. Again, we talked about the linear indifference curves from perfect substitutes, and then we've also seen some examples of perfect complements, which we'll see here. Right, we'll see the case that needs the most kind of math, I guess, or I guess really the only one that requires much calculus is the diminishing marginal utility case, where we have a multiplicative utility function. So we need to find the marginal utility of x, which is the derivative of the utility function with respect to x. And we need to find the marginal utility of y, which is the derivative of the utility function with respect to y. Then we take that ratio, the marginal utility of x over the marginal utility of y is the slope of our indifference curve. Right, so here's an example problem. Given a utility function 5xy squared, we want to find the marginal utility of x, the marginal utility of y, and then ultimately we're going to divide them and take the ratio. So when we do this, we're going to treat, when we're taking the derivative with respect to x, we're going to treat all of the constants as a constant, but we're also going to treat y as a constant. All right, so the constant, when we're taking the derivative of this utility function with respect to x, are 5y squared. Okay, so our derivative is going to be our constant, 5y squared. Remember, that's constant because we're taking this with respect to x only. And then we need to find the derivative of x with respect to x. All right, we just have this x left over that's not constant. Remember, that's x to the 1. So our rule is we're going to multiply our exponent by our variable and then subtract 1 off of the exponent. All right, so we've got 5y squared, there's our constant, times x, and we need to take the derivative of that with respect to x. The derivative of x with respect to x, this is x to the 1, so we would have a 1 times x to the 1 minus 1. 1 times x to the 0 is 1 times 1, which is 1. Right, so our constant 5y squared came along. We took the derivative of the x term with respect to x, which is just 1. The derivative of x with respect to x is 1. And so our marginal utility of x is 5y squared. Okay, now let's try it for y. We've got the derivative of u with respect to y. We need to figure out what our constant is. Right, here we've got a 5, that's constant. Our x is constant, and then we have this y squared term. So we've got 5x times the derivative of that y squared term with respect to y. We're going to bring down the exponent. We've got 2y to the 2 minus 1. 2y to the 1 power equals 2y. Multiply that together, we've got 10xy. Right, so one more time. We're taking the derivative of this term with respect to y. The y is squared, so we're going to bring down the square. We've got 10, x is a constant, that's coming along with us. 10xy to the 2 minus 1 is 10xy to the 1, 10xy. Okay, in case you're curious, how did we get from where the marginal rate of substitution, the slope of that indifference curve, was rise over run to this ratio of marginal utilities? There's kind of just a simple proof right here. Kind of more of, I guess, a 606 topic. If you sort of went on to go there, you would need to be able to understand this picture with the tangency condition, talk about the slope of that budget constraint, the slope of the indifference curves, and then you would need to prove why those were the slopes and why that tangency condition held. I'm not going to make you prove it. You only need to know that the tangency condition holds. You need to know what these slopes are so that you can find them and equate them. Okay, so finally, we need to find our marginal rate of substitution, which is the ratio of these marginal utilities we just found. So we simply divide them, 5y squared divided by 10xy, y squared divided by 10xy. The y is going to cancel, right? So the y squared, we can cross out a y here. So we've got, what are they doing here? Yeah, that's right. All right, and then we're going to divide this 5 down. We get y over 2x. Okay, so we've canceled the y's. We have canceled here. The x is there. All right, so now we know how to find the slope of the indifference curve, marginal rate of substitution. I'm going to do that by finding marginal utility of x, marginal utility of y, and dividing. Luckily, the only time we're really going to need to do much in terms of using this multivariate derivative rule is when we have a utility function that looks like this, multiplicative. We'll see in the example problems that I'll post a video of next that if we have perfect substitutes or perfect complements, the math is actually a little bit easier.